So with Algebra 2, we're going to get into an introduction with functions. And you may remember from an earlier class about a function being based off of how a y value can repeat. Oops. I changed colors in there. But the x value cannot. So x values cannot repeat. And again, you might be familiar with some different things. For one, the input or the independent variable is typically the x value, whereas the dependent variable or the output would be considered the y value. So we just have a kind of a word problem to start off with. An internet music service offers a plan whereby users pay a flat monthly fee of $5 and can download songs for 10 cents each. So as far as the variables go, a lot of times what we decide is the independent variable would be whether you're considering songs that they can download or the fee that they have, or how much money that you spend. So I know sometimes this could be confusing, but what I'll do sometimes is determine that the independent is, if you were trying to make a graph of this situation, which one is on the x-axis, or the fact that we have the word dependent usually means it depends on the other thing. So does cost depend on the songs, or does songs depend on the cost? I know it could be backwards, because some people might say, well, if I only have $10, then that would tell me how many songs I can get. But this problem is actually determined the other way. Like, imagine you had an infinite number of money, so how much money you have doesn't actually affect this. You get to decide how many songs that you want. So the phrase that they use is number of downloads. If you look a little bit further down on your sheet, you can see that the number of downloads is the x variable. And that kind of gives away the next answer as well, as the dependent variable would be the amount charged. So let me try to explain in a little bit more detail why the amount charged is the y variable. Is because if you decided that month that you're going to download 0 songs, just remember that you have a flat monthly fee of $5. You're going to be charged $5. But if you get 5 songs, well, if it's 10 cents per song, that means that they'll charge you 50 cents for that, but they'll also charge you the $5 monthly fee. So this is an example of a different month. If you decided to download 5 songs, that's how much you would be charged. Or if you went to 10 songs, well, 10 songs would cost you $1 added to the $5 monthly fee, and you're at $6. And if you go up to 20, well, 20 times 10 is $2 added to the $5 fee, and you get 7. So in this situation, hopefully you can kind of think what's happening here as far as an equation goes. And if you think back to Algebra 1, you might remember that the equation y equals mx plus b. So because there's a flat fee of $5, it's in part of the price no matter what. And the equation that you're going to come up with for x, well, it depends on how many songs that you have. So if you had 1 song, you would have to add 0.10 times 1 plus the 5. And if you had 5 songs, 0.10 times x, or 5 plus 5. Yeah, so from there, if you remember from Algebra 1, which I hope you learned this in Algebra 1, if not, just let me know. The equation y equals mx plus b, and you're asked to come up with a graph of that, you could say, okay, well, I remember that you started at 5, the y-intercept, and then you go up 0.1, right 1. But if you look at this graph, it's actually not counting by that amount. So it might be better is to look at our table and how we had at 5 songs it was 550. I think 5 is like right here. I have to scroll down a little bit. 556, 657. Yeah. So at 10 songs it was up to $6. And at 20 songs it got up to, and what you should see from this, if we start connecting these dots, that we're going to have a perfectly straight line in that direction. And if we follow the directions, it wants us to go all the way to 40. So what you can do is you can make, figure out what the value would be if you had 40 songs. So 40 times 0.1 would be $4 plus the 5. So if you got all the way up to this amount, I like to put an arrowhead at the end though to say that, hey, if we continued that trend, it would go on forever. And they also point out that you can use a calculator to generate additional coordinate pairs. So let's talk about that real quick. So as long as you have your calculator on and you click on your y equals, you can come up with the equation that we had, 0.1. You click this button for the x and then add 5 to it. And one thing to point out is when I go to my graph, some people might have some different viewing windows. And if you ever want to change the window that you see, it's going to be the window button. So if you want to change it the way it looks like on our problem, going from 0 to 40 on the x-axis and then 0 to 10 on the y-axis, we can change that. So 0 to 40 on the x-axis. And you don't have to count by ones. This one can let you count by twos or something else. And then the y values do go from 0 to 10, and again you can make your scale by whatever you want. So now when I go to my graph, you just don't get a grid, but there's ways that you can actually put a grid in there. But now my graph looks like that. It looks like the one from our problem. Notice how it's counting by whatever I said it was up until 40. And one more thing to point out before I move on is if I hit second graph, it actually comes up with a table of values. So you can see if you download one song, it would cost you $5.10. 2 songs is $5.20. So, and you can verify just by scrolling down, all of our values were correct. And all they did is they plugged 30 in for X and they got 8 for your cost. So on and so forth. There we go. So I don't think I need to write anything in that. And feel free to write whatever you need to. Okay, so here's another type of problem that has a relationship where y is a function of x and 1 does not. Okay, so if you look at the vertical line whose equation is x equals 3 on this graph, that would be right here, 1, 2, 3. And you're going to need to let me know if I'm talking about something that you've never seen before, or if you're confused why x equals a vertical line. You gotta let me know. I'm assuming you know that from Algebra 1. That's the first graph. Oh, gotta do it over here as well. 1, 2, 3. There we go. So in part B, give all outputs for the values in relationship A that intersect at our graph. So we went to 3, 1, 2, 3, 4. So relationship A was at 3, 4. But then there's also this point down here at 3, negative 4. And if you look at relationship B, it only happened at 1, 2, 3, down 2. So maybe I'll even color code relationship B as 3, negative 2. So which one of these is a function and why? Well, if you think back to what I had mentioned before, where functions have it so x's cannot repeat, that's what's happening in relationship A, that you have 2 different outputs for one input. So therefore, relationship A is not a function. And one way of doing this is what's called the vertical line test. And what the vertical line test says is if you were to draw a vertical line through any part of your relationship, that's what this is called, and it hits at more than one point, then you must have the x's repeating, and yeah, it is no longer a function. I've also heard of an analogy with vending machines. Imagine if you went to a Pepsi machine and one time you hit the Pepsi button and a Pepsi came out. I know it sounds weird, but then the next time you hit the Pepsi button, a Diet Pepsi came out. Would you say that that vending machine is functioning properly? I hope you would say, no, it's not. That might be a little bit too complicated of an example, but I've seen that before in textbooks. Anyway, so A is not a function, and I would just let you say that the x values repeat. I think that's a good, at least for right now, a good explanation. A better explanation might be saying there's two outputs for one input, which is a fancy way of saying that the x values repeat. Whereas relationship B is a function. You could do the vertical line test right there, that there's exactly one output for this input, and no other x values will repeat at any point. So no x values repeat is the explanation I'm giving you on that one. And I believe we have one more exercise where they give you this function, they give you the graph of it as well, and they start asking you questions. Now, right now this might seem easy for you, which is a good thing if it's easy. You've got to let me know if this is difficult. But I want you to get away from just looking at the graph and saying the y-intercept is where it hits the y-axis. While you're correct, I want you to take it a step further. So the y-intercept is 1, and what I care so much about is the y-intercept occurs when x equals 0. And that is always the case. What if the y-intercept was up here? I mean, it's not, but what if it was? The x value is still 0. Same thing with down here, right here. Every point on the y-axis has an x value of 0. So I need you to start thinking of the problem that way. So instead of looking at a graph, you can simply plug in 0 here and here, and you'll see you get a y value of 1. That's going to be very important this year, so get that in the back of your mind. And then you might be unfamiliar with the word integer. So I need you to get on board with integer is a positive or a negative whole number. And sometimes I might even say a counting number. Because we count using 1, 2, 3, 4, so on and so forth. But it could also be a negative or 0. That's why I use the word whole, because 0 is technically a whole number. So what are we talking about is the x-intercepts. So that's where it crosses the x-axis. And the one we care about is the larger. So the larger, maybe I should emphasize with a different color. Larger means further to the right. So the one I care about is this one. So as I start to count from the origin, 1, 2, 3, and 4, this x-intercept is between 3 and 4. Okay. And by the way, if anything I'm saying is confusing, you gotta let me know. This time they ask you for a horizontal line at y equals -2. So that's right here. And what they're at, and I'm assuming you know horizontal lines are y equals, vertical lines are x equals. So with these 2 points, we can actually find the values of x that solve that equation, because we're replacing the y in that original problem with -2. And so the graph is actually telling us that the solutions would be +1 and +3, because those are the x values for those intersection, and I will talk about this in class.